Hello, everybody, and welcome to today's webinar, Modernizing the Manufacturing Industry with MQTT and Kafka. We will kick off in a minute, but before we start, I want to give you a quick introduction. First of all of you are muted. However, you can ask questions during the webinar by clicking on the Q&A box in your control panel. There will also be a Q&A session after the presentation in which we try to answer your questions. If we can't answer them all, they will be answered on the HiveMQ community forum, and the link to the community forum will be shared with you afterwards. Additionally, we will also start a quick feedback poll during the Q&A session, and we would be really pleased if you could give us feedback. This is everything you need to know right now, and now I'm happy to hand over to today's speaker, Dominik Obermeier, HiveMQ CTO and co-founder. Hi, Dominik.
Hi everybody. So thank you for tuning in to today's webinar. My name is Dominik Obermeier. I am the co-founder and CTO at HiveMQ. I am a member of the MQTT technical committee at Oasis, and I helped specifying the MQTT standards, MQTT 3 and MQTT 5. And currently I'm involved in specifying MQTT for sensor networks. I'm doing regular speakings. I'm an author. And I also teach IoT at the university here in Germany. And I do a lot of speaking in national and international conferences. So, and by the way, if you want to connect, here is my LinkedIn handle, and also I'm active on Twitter. So if you want to connect afterwards or start a discussion, I'm happy to connect. So let's talk about the future of manufacturing. Manufacturing currently is undergoing a lot of change. So probably most of you have heard the term Industry 4.0, which is extremely popular in Germany, but also industrial IoT is a huge topic around the globe. And in general, this usually refers to this modernization process that is introduced by new technology, such as smart sensors, cloud computing, AI or machine learning, analytics, and so on. The business drivers behind this change are actually pretty straightforward. In general, it's really about improving the factory efficiency. And also it's about optimizing the intra-plant logistics and a more flexible manufacturing. So lot size 1 is really a gold standard. So especially here in Germany, the automotive industry is pretty popular with lot size 1 production, but this is of course also applies to a lot of manufacturing processes. And but not everybody can do this now, or sometimes it's not even desirable. In general, one of the most important KPIs for most factories and for most plants is also overall equipment efficiency. And a lot of the technology changes we see currently really have also to do with measuring and increasing the overall equipment effectiveness. So for example, it's about analyzing and increasing the quality. It's about tuning the performance of the machines and the processes, but also about increasing the availability of the equipment by avoiding standstill, which is unplanned. So this is something, obviously, that is really something people want to avoid. So let's talk about the current situation, though. And of course, especially if you're yourself active in this industry, not everything applies, of course, to every situation, but in general, what we've seen with our customers, the current situation is usually as follows. So the desirable state is to start with a Greenfield approach, but the reality is really a Brownfield approach. So most Industry 4.0 projects need to fit within the confines of an existing factory. And this can increase complexity of any modernization project, because if in a brownfield environment, old equipment cannot be replaced, or it's just too expensive, or it basically just works. So why should you change this? And also introducing change is something plan managers are often very reluctant, because the risk is too high. Downtime is really something you want to avoid. So there's a bit of a reluctancy also we usually see in some projects. So this might be a challenge, and is very often the current situation. Then another huge problem we very often see among customers is that data silos are the standard. So especially the factory equipments and the manufacturers of these, they produce lots of data, but it's very difficult to mix and match the data and to bring them together. And sometimes this is not even desired by the equipment manufacturer. So we usually have a lot of different data silos. But in order to get a holistic view of the whole plant, it's important to break these silos and work with the data actually, and also be able to exchange data. And this is a classic, I think everybody in the industry has experienced. This is really the clash of IT and OT, so from information technology and from operations technology. Because in IT, we have things like agile, we have data analysis, security of IT resources, and so on. But OT really is more interested in safety, in continuity, and in efficiency. And just because things work on the IT side doesn't really mean you can apply them to OT. So, for example, I had a conversation with somebody who had a pretty hard time introducing cloud-native technologies to a factory plant because, like, the mindsets is really very much different, and this required a lot of discussion and alignment. Also, what is sadly still the case for many plants is the manual interaction with OT software. So it's literally, sometimes it's the case that people go to their equipment and patch the machines manually with their laptops, for example, with a manual connection. Over-the-air updates aren't always, or sometimes are the exceptions. Not everybody can do over-the-air updates. And sometimes it's also not really possible or even undesired. But the problem is this makes it very difficult to scale. A software rollout, especially if you're managing multiple factories, this really is getting a pretty hard problem if we have different kinds of software and different versions of software deployed across in the same factory, or even across factories, or even if you're producing worldwide. This might be a challenge. Also, another problem we see in the current situation is it's difficult to scale and the hours of downtime. So basically, the technologies are pretty hard to scale. OT technologies are pretty hard to scale, but also, downtime, as I said, is really something to avoid. But if there is a downtime, especially caused by, let's say, failed software rollouts or something like this, this can also sometimes take very long. And so I've had the chance to observe this myself once when there was a major outage at a factory. And so this is really something unpleasant also for the business, because the business is losing money. So it's really about avoiding downtimes at all costs, because this is hugely expensive. But still, modernization is important, as we've seen, because by the business drivers. And usually the goals we see is that, I mean, software is eating the world, which Andreessen Horowitz said. This is also true, and software is also eating manufacturing at some point of time. And what we observe is that more agile software delivery into factories are our goals. So being more agile, which means reacting to change in a more sophisticated way. a faster mean time to recover in case something goes wrong. It's important that this time when something goes wrong is as short as possible. It's also about enabling centralized command and control and enabling visualization of overall manufacturing process. And what is also very desirable to be future-proof is having a consistent and a flexible software architecture. So when we actually look at how you usually segment the different let's say levels of on the factory. So we're usually going from shop floor to the top floor. And so what you see here is on the one side, we have on this pyramid with the different levels, and you see that the time which you usually think in depends on the actual level you're in. So for example, if you're on the field level, which is the production process itself, it's really all about milliseconds or about microseconds. When you go on the PLC level, on the control level, which is of course also still on the shop floor, we're usually talking about seconds. So PLCs are, so these are real-time applications. So we're talking about seconds here and also about predictability of how long things actually take. So this is very important from on this level. When we go into the domain of the SCADA or HMI systems, or even the MES systems, this is really where more the higher level things happen. So on level 2, we're talking about monitoring and supervising, while on level 3, it's about manufacturing operations management. And this is where MES systems usually come into play. And then on the level 4, the corporate level, this is where usually the ERP systems deployed reside. This is about planning and logistics. This is really about making sure on a high level that everything works as expected. And this is, and the higher levels, so the top floor parts is where, from a management perspective, things get more interesting. And also, you usually also want to integrate with the rest of your enterprise. So it's not uncommon to use this data and also bring in data from other sources in order to aggregate them and to have sophisticated reporting. I'd like to talk about three patterns which we usually observe. And I'd like to talk about connecting the factory by intra-factory connection, by inter-factory connection, and also talk about an industrial IoT bus, which is something we see a lot in customers in the manufacturing space, in the production space. Let's start with the intra-factory level. So we have now introduced the different levels, and now I'd like to segment this a bit more. So I'd like to talk about an automation area, which is level 0 and 1. This is really machines and PLCs. Level 2 and 3 is the manufacturing area. This is where we have the SCADA systems and the MES systems. And then I'd like to talk about the factory area, where it's where we do especially reporting and analytics, which is important. This is where the product lifecycle management happens. This is where the overall equipment effectiveness is usually measured. And then level 4 is cloud. And so we haven't talked about cloud yet, but cloud today is also something that is very important. And a lot of companies are thinking about cloud, but are also especially thinking about when to move to the cloud, what kind of data to the cloud. And of course, very often the discussion is what type of cloud do we want to use? So this is intra-factory when we talk here, and we will talk about the communication patterns here. So we'll talk about technology very soon. I'd also like to introduce another pattern, which is also for larger customers. We see this a lot in Fortune 500 companies with a lot of plans. This is the inter-factory communication. So on the one side, of course, you have your factories itself, and they need to work, obviously. But usually, and this is usually in the cloud, sometimes a private cloud in your own data center. Sometimes it's a public cloud where this resides. And this is, I call this here the enterprise data center. And for some customers, this might also be that there are multiple data centers. So this is really just an abstraction here to make it clear. And the idea is here to connect all these factories, probably over the internet or through a VPN, to the enterprise data center, where we aggregate things from a lot of different factories, do some data analytics there. This is where your data lake usually resides. And this is where also machine learning happens. So especially if you want to do predictive maintenance, it makes a lot of sense to have data from all your factories and plants around the globe, for example. So this is also something we need to talk about, how to connect like factories to the cloud. And then I'd like to talk about a factory IoT bus, or this industrial IoT bus. So we've talked about the automation area and also the other areas here. And this is something we have seen as a new pattern emerging for a lot of customers. They're introducing a bus system, which especially also brings in new smart sensors they're deploying to have additional data they can rely on for more predictability in the automation process. But also more and more applications are deployed also inside the factory, which might even be, let's say, sometimes cloud native technologies. And an IIoT broker, which is usually done via MQTT, can connect from sensor to the cloud in one logical abstraction. But again, we will now see how the technology actually fits in. There are a few technical challenges when you think about the patterns flow. And this is what you really need, what you really require from sensor to cloud. And for all these patterns, you need a reliable and bidirectional connectivity across all the levels of automation. And also what you usually want is a consistent data messaging across all areas. You don't want to reinvent the wheel, and you really want to be consistent and be future-proof. And security becomes very important when the things are connected. And this is something that is, from my point of view, sometimes neglected. And this is really something that is extremely important. Security is not a feature. It's not something that can be enabled later on. Security is something that needs to be done by default. And especially if we connect things to the internet, either directly or indirectly, we really need to make sure that security is a concern that is clarified, hopefully in the beginning of a project, because so there are so many examples of companies who had a downtime of sometimes multiple days or even weeks because they got hacked. So security is extremely critical. And then we have another challenge, and this is that lots of different hardware suppliers use non-standard protocols and platforms. And this is what I was talking about with silos. So fortunately, this is now breaking up a bit, and most vendors now also provide standards connectivity. But this is something that is really important to have compatibility between machines, or at least make sure to get data out of machines, or you can put some commands back. So this is a technical challenge, and I think this will remain also a challenge. So this won't be solved by introducing the software, but this is an undergoing change in the industry. And fortunately, it seems that a lot of vendors are now in the process of supporting standard protocols, which is very good. So now let's talk a bit about technology. What we usually see, especially when doing the intra-factory. So Of course, if you want to talk with sensors and with a PLC, you have these native protocols. You also sometimes have a gateway, which translate industry protocols and multiple industry protocols to the other levels. And what is really great to see is that MQTT is something that is getting immense traction. And if you're not sure what MQTT is, I will explain it in a minute. And MQTT is used for connectivity, especially inside levels. So the gateway, for example, could also communicate with the machines, or the PLC could, and the PLC would then, of course, use direct communication. But also, even for example, Siemens also has native, with their PLCs, they offer native MQTT nowadays. So even a Siemens S7 could publish and subscribe data directly over MQTT, which is really great to see. And then MQTT is then used to connect the different automation areas. So you usually have multiples of them with the systems like the MES system. And after this is where another technology very often comes into play, and this is Apache Kafka. If you're not sure what this is, I will also explain in a minute. And here it really starts to get a bit unclear. Do you use Kafka or MQTT? This really depends on what you want to achieve, but I will help you categorizing what technology, and this is what we see a lot. So a lot of MES systems have native MQTT capabilities, but also native Kafka capabilities, as well as some of the SCADA systems. What seems to be more popular, though, is to have approaches like Sparkplug, which is an industry standard communications protocol on top of MQTT. But we won't dive into the details here, but I can talk a bit about Sparkplug later on in the Q&A section if this is interesting for you. And then to level 3 and 4, you usually also connect this, because we're still inside the factory, you connect this also via MQTT and Kafka or Kafka. And then if you're in the factory area, very often you want to use Apache Kafka directly. But also it could be that we have customers who do MQTT, but very often Kafka is something that is really popular. The thing is, if you're doing cloud connectivity, you really should do MQTT, because the Kafka protocol is not designed for internet communication. You can, if you really want, you can try to make sure you have a really stable connection to the internet, and then probably also use a VPN. But it turns out that MQTT from level 3 to 4 to level to the cloud, this is really something you want to use MQTT, but we will see this in the inter-factory pattern. And also here, across all these levels, the IIoT telemetry broker comes into play, because you could push directly data to this bus, or you can enrich things and provide additional measurements, like, for example, vibrations and so on, to this IIoT broker. So you can push this directly to the cloud over MQTT, and then use your analytics applications in the cloud. Let's talk about Apache Kafka for a minute. Apache Kafka, for people who are not aware of it, is a distributed streaming platform, which is very popular amongst Fortune 500 companies, but also let's say, from startups to large-scale companies. It's a very popular project on GitHub. It's the most popular Apache project, actually, and it's open source. So this is nice. There are, of course, also vendors for Apache Kafka. For example, we have a partnership with Confluent, which is one of the main maintainers of Kafka. And we make also sure that we play as HiveMQ very nicely together with the whole ecosystem, especially large vendors like Confluent. And Kafka is really a central messaging and distributed stream processing application, and it's usually used in the cloud for backend applications, but it's nowadays also used on the edge or in this case, in the factory, but it's really not a good technical solution for connecting clouds over the internet. The strengths for Apache Kafka, it's optimized to stream data between systems and applications, and it's extremely scalable. So to make it clear, neither with an application like HiveMQ nor with Apache Kafka, you are expected to run into any performance problems, because also Kafka is really designed for scale. And it's really perfect for inter-system communication inside a trusted network and with stable IP addresses and connections. And if you have a limited number of producers and consumers, which means a limited amount of applications communicating over it. And so it's not used for sensors or large-scale deployments where you have a lot of endpoints, but it's more used really for application-to-application delivery. And so you can imagine really Kafka as this huge a box where you just put in your applications, produce and consume data from it, and even connect your databases or other technologies directly. It can even be used, for example, to integrate legacy things. So for example, if you find yourself having technology like messaging systems, like WebSphere MQ or TIBCO systems inside your factory, or if you have them, you can easily migrate also to Apache Kafka by integrating this data to Kafka. But as I said, it's not only about Kafka. Especially in the shop floor, you see a lot of MQTT nowadays, and this is for a reason. So MQTT is an IoT messaging protocol, and it was designed 1999 for SCADA systems, actually, for connecting SCADA systems over the internet. So, it was invented by R.L. Nipper and by Andy Stanford Clark, who are also nowadays still evangelizing the technology. And it's by far the most popular IoT messaging protocol, and now it's taking over the industrial Internet of Things. It's based on the publish-subscribe mechanism, which is completely different to not so scalable protocols like OPC UA, which is on a poll and response principle. And MQTT is extremely scalable because of the publish-subscribe principles. It has a minimal overhead for the client and for the bandwidth. This is very important if you're doing connectivity over the internet. And it's designed for reliable communications of unreliable channels. Also the internet. So if this is what I meant when I said, if you connect a factory to the cloud, you really want to do MQTT because cloud connectivity is unreliable. And it offers different quality of service levels, so it can exactly fit your needs. And MQTT5, which is something we specified, also we at HiveMQ helped specifying, has a lot of the features you actually require for industrial Internet of Things from our point of view. I won't go into details here because of time, but if this is interesting for you, reach out to us and we will help you understand how your application will benefit from this. And we have actually also, I think, a few webinar recordings where you can learn more on our YouTube channel, if this is interesting for you. So how does this work? So MQTT uses a central communication piece called MQTT broker. And this MQTT broker is used for distributing data at scale. And we have usually so-called subscribers. These are applications who subscribe to specific data. And we have publishers who publish specific data. So for example, in this case here, we have a smart sensor which is pushing data to an MQTT broker. And all machines or all applications which subscribe to the data will receive the data directly. And this could be like a Siemens PLC. This could be even a Java application, a C application. This could even be a mobile application if you want. So you really can connect anything to this broker and in a scalable way. For the same piece of data, you could have literally up to millions of subscribers which will receive the data directly in a push style, and you at the lowest latency available. So especially if you're in a factory, it's yeah, we're talking about milliseconds usually here. So, and lower milliseconds. So this is really extremely fast, and this is actual push communication, and it scales well. So for example, to give you a bit of a feeling how well it scales, so it's enough for most factories I know of. The same technology is used for connected cars, and we have customers connecting multiple millions of connected cars with this, who push data at an aggressive pace from device to cloud and from cloud to device. So this technology, you don't need to worry about scale. Okay, now as we have talked about the technology pieces, let's go back to connecting the actual factory. So let's talk about intra-factory again. As we have seen, MQTT from level 0 to 1 and level 2 and 3 is used. What is required is bidirectional messaging, and you really want a lightweight protocol. And MQTT is one of the most lightweight protocols you will ever see. So it's like a bit opposite to OPC UA, which is rather bloated. MQTT is extremely lightweight by design. And most MES systems support MQTT nowadays. So if you're unsure, talk to your MES vendor. Most of the popular support this nowadays. Also PLCs like a Siemens S7, they provide MQTT support out of the box. And also most of the gateway manufacturers, if you have gateways deployed or planning to deploy gateways, most of the gateways vendors do support MQTT directly. And then what I said in the other levels, you can use MQTT if you already have the broker, which is nice. Or you can also use Apache Kafka if this fits your need a bit better. And to cloud again, I would really recommend to go MQTT. Sometimes it's smaller scale. People try to use Kafka for this, but we got better experiences from our customers when using MQTT directly. Now let's take some time to talk about another important thing. This is the inter-factory communication. And the inter-factory communication has also two parts, and Kafka also plays a role here. So when we're connecting inter-factory, what you usually do is you have the broker or the brokers deployed in the factory. They use a mechanism called bridging to a centralized MQTT broker in the enterprise data center. And so this enables you to basically filter data. So because usually you don't want to send each data stream you have or every data stream you have to the cloud. Most often you have data that is important to have locally, and then you have data you want to push to the cloud. And for example, if you do some edge computing, and you want to push the results to the cloud, you can do this because HiveMQ and the bridging of HiveMQ allows filtering of data streams. So you only push their data to the cloud, which you need, and you can also bring in data from the cloud in this push notification style to the factory, but only this kind of data you really want to have. And from there, usually you integrate in the cloud, because here in the enterprise data center, here we're talking about scale. So especially when it comes to data throughput, so it could be for large deployments that you have 6 digits of message rates, so like more than 100,000 messages per second you receive from all your factories, and you also push back to factories. And then you want to pump this to a data lake, you want to do some analytics. And this is where technology like Kafka really shines. Kafka is a persistent messaging technology where you can dump in data and then pick it up later if you have computing time available or if you want. The MQTT broker should be really, the data should be fresh here. So while MQTT can queue data and you can use it as a message queue, what we recommend here is if you have massive amounts of data and push them to Kafka and then consume them with your data analytics service, your machine learning services, and so on, either directly from Kafka or from a data lake. And this highly depends on your cloud architecture. This would be a complete different webinar, but we also talk about this kind of architectures in our webinars. So if this is interesting for you, reach out to us. We have recordings for this, and as well, we have some upcoming webinars. So why is MQTT so important here? MQTT relies on the standards the whole internet relies on when it comes to security, TLS. Every bank, military services and so on are encrypted by TLS, and you can use the same technologies here, which is great. And HiveMQ is designed for high availability. So high availability means even if let's say one machine where HiveMQ is running breaks or is not available anymore, or the internet is flaky, the connectivity is flaky, you have other HiveMQ instances, other HiveMQ brokers who make sure that you would basically take over, so you have high availability out of the box. And the same is also true for the factory. So you usually have a high availability deployment in the factory and also in the cloud, and then you bridge data between cloud and factory. So how does this look like? Usually you have this MQTT broker cluster, and then you push the data to the cloud. To Kafka. And for the MQTT applications and devices, this is usually transparent. So we don't even know that you have multiple MQTT brokers. So you can scale these up and down as needed. So especially for people who are familiar with cloud native technologies, very often you would also see technologies like Kubernetes in the play here, which scale the brokers up and down as needed. The thing here is, and this is important, if you want to use Kafka here, you need a first-class integration of your MQTT broker and Apache Kafka, which makes sure, even if things fail, that no data is lost at any circumstance. So if you're already a HiveMQ user, we got you covered. This is exactly what this is built for. If you're using an open source broker, for example, check with your vendor what happens with high availability, or even better, test it yourself. And if you want to test and you need help here, we have tools which we release pretty soon to the public, but we have an early access, which is called the HiveMQ Device Simulator. So reach out to me directly if you want early access, and if you want to test what happens at scale if things fail, if you are using another broker software. So we can help you here benchmark, basically. So what are the implementations options for all the technologies? So on the one side, if you're in the Kafka ecosystem, you could either run Kafka your own, or you can use a platform like the Confluent platform, which makes it easy for you to run Kafka and has some additional features. So on the Kafka side, but so if you need help here, Confluent, for example, is a very good partner of ours, and we have seen projects like these I'm talking about in this webinar. So reach out to me, and I will make sure you get the right person, which can tell you what the best option here is on the Kafka side. If you're going to the MQTT side, we have different options. Like we have the so-called enterprise MQTT platform, HiveMQ, which consists of a so-called control center. We have a lot of metrics. You get observability to basically anything, to all machines. We enable you enterprise security. HiveMQ integrates with all systems you usually have. So if you're using an Active Directory, for example, for managing your machines, or an LDAP or a database, HiveMQ can connect directly to this. So device management gets pretty easy with MQTT. And you can also do permissions here. So because you really want to make sure if you connect your PLC to the broker, that nobody also using the broker is just sending anything production critical to your machines. You really want to avoid this. I already told you that high availability clustering is something most of our customers use. And we have a lot of extensions, like the Kafka extension, which I will talk about in a minute. But also open source, especially if you're on a tight budget or if you're getting started building POCs, you don't need to invest at all. So HiveMQ is open source. The HiveMQ community edition is open source. You get the whole MQTT standard for free, basically. Also with an extensions framework, so you can also build your own integrations. It doesn't come with high availability though, but for proof of concepts, this is perfect. And a lot of customers are starting with the community edition if they're not ready or don't have budget assigned already for an MQTT solution. So you can really go with the HiveMQ community version. And also, by the way, HiveMQ Professional and HiveMQ Enterprise are both also free to use up to 25 connections. So if you only want to do a proof of concept, you could also go with the full-fledged professional version. We have a Java MQTT client, which we developed together with BMW for production and mission critical use cases. So this is something a lot of customers are also using if they're on a Java stack. And for testing and for developers, we have the so-called MQTT CLI, which is also free and open source. It's the Swiss Army knife for all developers doing anything with MQTT. It's available for Mac, Windows, Linux, so you can run it everywhere. So this is really, even if you're not on the HiveMQ ecosystem and you're using other brokers, the MQTT CLI is the Swiss Army knife, which works with everything related to MQTT, independent of any vendor. So HiveMQ itself, I already told you this, important, it supports MQTT 5. If you want to go, with the MQTT route, make sure to use MQTT 5. MQTT 5 was released 2018. A new project which doesn't use MQTT 5, I would really urge you to make sure MQTT 5 is supported. Most vendors support this, but please make sure that your vendor supports this, because otherwise you're now starting with a pretty old technology if you're using the old version of MQTT. So make sure to use MQTT 5. So HiveMQ as a company so we are doing business with a lot of customers in the manufacturing space. So our customers usually build new digital products, improving customer experience and creating more efficient operational insights. And of course, connecting factories, and this worldwide. So from the US to Asia, we have customers connecting at large scale, and many of them Fortune 500 companies. We also have some case studies online, for example, with Daimler. So you can also check them out on our website if you're interested what these customers are doing. So we integrate also with Kafka directly, and this is with a so-called enterprise extension. This is basically a module you just install with your HiveMQ installation, and then you get bidirectional messaging between all your devices and Kafka. It scales to millions of devices in case you need this. Usually in a factory settings, you don't have millions of devices, but this is really battle tested for mission critical workloads, and is used around the globe for 24/7 operations of critical manufacturing processes. And we also integrate seamlessly with the Confluent platform and also Confluent Cloud with advanced features like schema registry, role-based access control, and so on. So if this is interesting for you, you can always reach out. We're happy to help you understand the advantages here. But basically, it's just a module you plug in. If you're a HiveMQ user, you can just enable Kafka, and then you're good to go with a production-grade installation. So, which works also in the cluster. This is highly available and uses the native Kafka protocol. So you can use a vanilla Kafka. You don't need anything special here, and it really scales and makes sure no message is lost in any case at all. So yeah, which is really HiveMQ and Kafka is really really awesome technology stack. A lot of we see a lot in customers deploying. And yeah, and we expect to see a lot more here. So yeah, we have also published recently a white paper, which is available under this link. And also, if you miss this link, you can also reach out to us. We're happy to send it to you, which will also summarize a bit of the contents here. So it's, I think, 10 or 12 pages. You can just download it for free if you want to have a summary, basically, of this webinar. Okay, so we have now a bit time for questions. Before I start with questions, let me tell you one thing about Sparkplug. Sparkplug is a specification which we are also specifying together with a lot of other industry players like Chevron, like Cirrus Link, and is used also a lot in the manufacturing space. You can expect a lot of content about this pretty soon. This is still in early stages, the specification, but already customers are using this for production deployments based on MQTT. It makes a lot of the things easier, which we talk about, because it implements patterns directly. So yeah, if Sparkplug is of interest to you, so again, we will do a lot of content here, also webinars. We will announce also a few things soon about this. You can also get in touch with me directly if you want to learn more what we're doing here. I'm more than happy to talk with you and how this could benefit your use case. Having that said, I think we now have some time for questions.
So let's see, we already have a few questions here.
Okay, so yeah, we have a few questions here. Let's see. What is the best method of smart sensor to gateway communication? Okay, this really depends on the sensor. So there are a lot of industrial protocols. Usually a good gateway can connect most of the things. They can connect PLCs, they can connect sensors and so on, either over MQTT directly, or all the protocols, the proprietary protocols you have in the factory. And also all the bus systems you usually have. So this is really something your gateway vendor should provide. Sometimes you see here also OPC UA, which is also, especially in Germany, pretty popular. It's very, very heavyweight though, but this is also sometimes used here. So really for the best way, I would say if you're going to an MQTT stack, in an ideal world, you could use MQTT directly. But I said this already, we usually have a brownfield approach, so you cannot always rely that you have MQTT support. So usually you need a gateway, and a sophisticated gateway will translate between all these. If you're going the open source route, which can be an option or not, but you have seen some companies exploring this. There is an open source project called Apache PLC for X. It's called PLC and then 4 and then X, which can be used with Java to read and write to a lot of proprietary protocols. But yeah, I haven't seen this in production yet.
Okay. Then we have another question by Ben.
Yeah.
Ben asks, does HiveMQ support MQTT SN?
Very good question and very relevant question, actually. So MQTT SN, for people not familiar with this, is MQTT for sensor networks. And MQTT SN is not an official standard, which can be used, but this is a standard currently we, like IBM and also HiveMQ and other companies are specifying under the OASIS umbrella. So this will be released hopefully next year, and we will be one of the first MQTT SN implementations, which is standard conformant on the market, similar to what we did with MQTT 5. So we really want to make sure to have something here. For now, we do not support MQTT SN yet, but you won't see MQTT SN a lot yet. But I expect that, especially for the sensors, this will be one of the dominant protocols. Okay. Yeah, so there's also a comment that OPC UA users also publish a subscribe model. Yes, this is true. The OPC UA pops up. which is great because it also uses MQTT under the hood. So this is, I think, very relevant for people already using Opus UA. You can use PubSub, and one of the options as a transport protocol is MQTT. If you want to bring Opus UA and MQTT together, this is supported out of the box. So it's a very good comment. So thank you for that. So another question which we got is, what are the requirements for Kafka? Stable TCP connections between source and target. Yes, this is one requirement. Usually also for Kafka, you need a lot of disk space and also some compute power. So you want to make sure to have this run on server grade hardware. If you want to run this in the factory. So in general, yeah, if you have server grade hardware, it works, but you really need a lot of disk space. And also stable TCP connection. So, and otherwise it really depends on what you want to do. But usually Kafka can be deployed very easily and really works if you have applications who can communicate with Kafka. We got another question. Can Kafka also be used within a device for inter-process communication? I think technically, I have actually never seen this. Technically, it could work, but for IPC reasons, I actually wouldn't go with Kafka. So there might be some situations where this is appropriate, but I haven't seen this personally and don't think this is the obvious first and best solution. Okay, is there a CLI option that we can use to communicate ad hoc with MQ? So I guess this is MQTT. Yes, the MQTT CLI, which I talked briefly about, is a command line tool which you can use. You can install it. It's available on GitHub. So you basically can Google MQTT CLI, and then you see a GitHub project which is used here, and you can install it with your favorite package manager for Linux, Windows, and for Mac. So in case you're not able to find it, please reach out to me. My email address is dominic@hivemq.com. So reach out to me and I will make sure you will get the link sent. Okay. Okay, we got also a question, which is, how does related solutions handle time series data? Or are there specific date formats that are limited? So this is a good one, because usually with IoT in general and also with industrial IoT, time series data is important, and much data is actually formatted as time series data. So the different ways you could handle this. Usually, if you're going the Kafka route, you have a time series database like time series DB or like InfluxDB, or you're using one of the, let's say, cloud vendors' native time series database where you pump in your data. The great thing is with MQTT, data is in sequence. So you can make sure you get data in sequence. Also within Kafka, data is in sequence if you're in the same partition. So you can pump this to a time series database, or you could consume it directly if you have a use case here. But again, best practice is use a time series database, which is available from most vendors. So you could either go the open source way, like an InfluxDB, using InfluxDB, or you could also go to your favorite vendor like IBM, and they will also gladly tell you about this kind of software. Okay. So we have another question. I am an IoT hardware developer. So what is the standard protocol of hardware? So this is pretty similar to a question I already answered. This means it really depends on what hardware you want to integrate. Usually on this level, you integrate with the native protocol, so you usually need to check with your vendor. But most gateways or many gateways support a lot of hardware platforms directly. Then we got a question regarding security. So for better security, any recommendation on selection of operating system for the broker, Windows or Linux? So for security reasons, I think best would be to go with what your IT security recommends platform. So HiveMQ, for example, is able to run on Windows as well as Linux. For large scale use cases, we recommend actually Linux, but for most use cases, Windows is solid, and we have a lot of customers in the production space running on Windows machines. So in the cloud, we would recommend Linux, but if you're on the factory floor somewhere, if you happen to use Windows, use Windows by all means. So this is not a problem at all. Okay, I think we can do 2 more quick questions. In the Kafka extension, is the Kafka extension tied to Confluent Cloud, or can it be deployed to other platform providers such as Azure? Yeah, so it's not tied to Confluent at all. It's any Apache Kafka distribution, be it AWS, MSK, I think is the name. The managed service for Kafka can be used. You could use also Azure, which is also, I think the event hubs have a Kafka API, so you could also use this. Important is it must implement the Kafka protocol. So from a vanilla Kafka installation on your machine up to a cloud provider offering, you can do any Apache Kafka integration you want. If you want to have one of the more sophisticated integrations like a schema registry integration, then I would recommend to use a hosted or a self-operated Kafka platform, Confluent platform, because this is proprietary from Confluent. But most, again, if you just want to vanilla Kafka, you're free to use any Kafka.
Okay, I think one quick question.
Mm-hmm. Okay, so okay, so there's a question if we can resend the if there will be a replay of this webinar. Yes, so there will be a replay of this webinar. So we will send out a link to the recording in case you missed some parts here. So no problem. And I think last question. There's a question called can MQTT be used for streaming data? So yes and no. If you want to do like image streaming or video streaming, this is not optimal. If you're talking about streaming in the sense of a lot of messages in a very short time frame, absolutely. And so we have customers who are doing like 10 messages per second, which they send out to the MQTT broker per client. So yeah, but in the end, it's messaging. It's not really streaming. It's messaging. So yeah, it's in the definition sense of streaming. It's not streaming, but people use it conceptually to stream data from one point to another point.
Okay. And I think that's it. And for all of those questions that we couldn't answer now, we will answer them on the HiveMQ community forum. So thank you for joining us today. As Dominic just mentioned, we will upload this webinar also on our YouTube channel. We will send you the link also tomorrow in a follow-up, and also with the community forum link and the link to our manufacturing newspaper. I hope you enjoyed the session. Thank you, Dominic, for the presentation, and see you next time.
Yeah, thanks everybody. Take care.
Bye.